So before the break, what we had been working on was how to solve quadratics. We solved them by factoring and by graphing and by square roots. All leads us up to solving by the quadratic formula. There's so many choices when it comes to solving quadratics that sometimes it's hard to choose which method to use. If you want one way to always do it, this is the method you would use. It is called the foolproof method, which means you really can't mess it up unless you mess it up. The foolproof way to solve any standard form quadratic, so A's, B's, and C's. In the Kahoot or Gimkit, what is that, Blue Kit we just played, you were asked a few questions like what is A, what is B, what is C? Remember that A is the number next to x squared, B is the number next to x, and C is the number straight up by itself. And if we can identify those three things, A, B, and C, then we can fill out what's called the quadratic formula. This formula is going to be a way to find the solutions by just plugging things in. If you notice, this formula has two spots where you're going to plug in the number B, two spots where you're going to plug in the number for A, and one spot where you're going to plug in the number C. Every single time you use this formula, all you have to do is take the numbers from the equation and place them in the formula and then simplify. Now the simplifying part is the only part where you have to remember some steps because sometimes we'll get ugly decimals and we don't want that. So we'll have to go slowly, being able to reduce down the quadratic formula as we use it. One note you might want to make for yourself is when you are using the quadratic formula, you're going to use lots and lots of parentheses. Whenever you plug a number in, you should plug it in parentheses. So that is 1, 2, 3, 4, 5 sets of parentheses that I should see at every single problem. For every letter that you plug in a parentheses as well. Now this formula is on most all formula charts. It's on the formula chart you will be given for your DCP, which is next class. But it is really fun to just memorize. Do y'all know the song Pop Goes the Weasel? Or the tune of Pop Goes the Weasel? It's like an old nursery rhyme. I don't know. I actually don't remember the words to Pop Goes the Weasel, but I do remember the words to the quadratic formula. And you can sing it to the tune of Pop Goes the Weasel. Perfect day for me to have kind of a rusty voice sounding today, but I'm going to sing it for you. Okay? It's to the tune of Pop Goes the Weasel. Are you ready? You're just going to read it off the page. Ready? It goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is where you clap and applaud my singing. Thank you. Or not. We're all asleep. Okay, thank you. Yes. Amazing. +5 for you. Okay, so it goes to the tune of Pop Goes the Weasel. You don't have to memorize it because I'm always going to give it to you, but it's annoying to always have to look stuff up. We should memorize things every once in a while. This would be something in your math career that I recommend memorizing. Goes to the tune of a song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're gonna do a sing along now. It's y'all's turn. I'll sing with you, but you're gonna sing along with me. We'll go slow. Thank you for singing along with me. That was fun. Okay, so the quadratic formula, like I said, I'm gonna give it to you. You don't have to memorize it. It's on most formula charts. You can Google for it, but it's really easy to memorize. So why not do it? When we're using the quadratic formula, what we're going to do to start simplifying it is work with what's called the discriminant first. Everybody say the word discriminant. The discriminant helps us decide how many and what type of solutions we'll have for that problem. Because if you remember, when we were dealing with quadratics, we learned that we can have two real solutions where the graph crosses the x-axis twice. We can have one real solution where the graph crosses the x-axis one time, and we can have no real solutions where the graph never crosses this x-axis. Last time that we learned something new, so before the break, but not right before the break, we learned that this was not just no real solutions, but in fact, two imaginary solutions. That means that these are going to have what letter in them for imaginary? I. They're going to have I's in them. Now this discriminant, which I kind of glazed over real fast, helps us know these different types of solutions. Where do you see this discriminant, this formula, in the quadratic formula? Where is it? Underneath the square root. So really, the discriminant is just the stuff underneath the square root. Each of the letters used only once. So if you really wanted to write that, you totally could. You could say the discriminant is the stuff under the square root. That has a name. It's called the radicand, but you don't need to know that. Stuff under the square root. If we figure out what the stuff under the square root is equal to, we can decide what type of solutions we have. If that discriminant is positive, so if you multiply all those things and subtract 4ac and you get a positive number, you will have 2 real solutions for your answer. If you figure out the discriminant is the number 0, you will have 1 real solution. And if you calculate it and that discriminant is any negative number, then you're going to have 2 imaginary solutions. So that discriminant helps us know exactly what type of quadratic we're dealing with right away. And all we have to do is plug numbers into it, then figure out if it is positive, 0, or negative. Okay? Now, none of this makes sense till we start seeing some examples, so let's go into the inside and let's see some examples. If you notice here, I have given you a visual representation of the quadratic formula. If you work better with shapes instead of numbers, here's the shapes and the numbers and the letters put together in the quadratic formula. So that is there for you as a resource. You could plug the numbers into the different spot if you wanted to and then erase them every time. However you want to use this, I think it's helpful to kind of see that. You have the same quadratic formula. But in exercises 1 through 3, it says find the discriminant of the quadratic equation. Remember, the discriminant is just b squared minus 4ac, the stuff underneath the square root. Then we're going to describe the number and the type of solutions for the equation. So first, because the discriminant needs b, a, and c, we need to figure out what the b, the a, and the c are. In example number 1, what is the a value? It's next to b squared. What number's there? 1. Very good. Okay. What is the b value? 34. It's the number next just to regular letter. And what is c? 289. Cool. I know all of the things that I'm just plugging into my formula. My formula was b squared minus 4 times a times c. That's the discriminant formula. We just need to plug those numbers in. It's really that simple. So we're going to take the number for b, which was the number 34, and I'm going to put it in parentheses. You must put it in parentheses. It is so important to put it in parentheses. Yes, ma'am?
I thought that one right there in front of the b.
Oh, that's the problem number.
Yeah, that's what I was trying to see.
But this right here, an invisible number in front of a letter, is still the number 1. That's a really great question. So we could write in the 1 right here if you wanted to show it. The 1 period is the problem number for this problem. Okay, so we have 34 squared, making sure we put it in parentheses. And we're going to subtract 4 and then open parentheses and put the letter A, or the number for A. And then another parentheses and put the number for C. Do you see how every single time I plugged a number in, I used parentheses? You must do that. It is required to get the problem right. Otherwise, you will mess it up when we type it into our calculators. Because at this point, all we need to do is figure out the value for that discriminant. So we're going to use our calculators. Now, again, pre-cal uses your calculators as well, so you need to reset them every time you pick it up. How do you reset it? Second plus 712. Thank you, heard it. Okay. All we need to do is plug in the numbered version of this formula with the parentheses and everything. So I'm going to start with an open parentheses. Let's see if I can make this. I don't think I can make it any smaller. Open parentheses, 34, close parentheses, squared. Exactly as I have it written on my paper. Minus 4, open parentheses, 1, close parentheses, open parentheses, 289, close parentheses. Do you see how it's exactly how I have it written on my paper? The same thing will work. If you go home and you use Desmos for these problems, the same thing will work, but you need all the parentheses for both the calculator and Desmos. When we press enter, it's going to give us a number. What number did it give us? 0. Okay, so we found out that the discriminant is 0. What does that mean for us? What type and how many solutions will we have?
One real solution.
One real solution. Very good. The discriminant being equal to 0 means we have one real solution. And it's going to be at some particular number that we don't know. We just know from the discriminant how many and what type. Yes. So I wanted to make sure that you know the difference in these calculators from this. Let me type it in wrong. 34 parentheses squared and then minus. Did y'all use this minus?
Yes.
That's a negative. The calculator has a difference between minus and negative that Desmos does not. For Desmos, you can use the same button for each one. But if on the calculator you use that negative as a minus, it's going to be multiplying all those things together and give you a ginormic number. So you make sure that when you're doing the discriminant, you don't use the negative sign, you use the actual minus on the calculator. So it should look like this with a big minus. See how it's a little bit bigger than the negative? That's a good check for yourself. Make sure you use the correct minus sign. Okay, let's try another problem. So for number 2, we still want to figure out that discriminant. But right now, is that equation set equal to 0? No, in the blue kit that you did right before we started, we said that all of the equations need to be set equal to 0 for us to solve them. So we have to do 2 little bitty things to move this equation and make it equal to 0. One of those things is to do this. Why would I do that?
Move it to the other side.
Very good. I'm moving it to the other side. When I move it to the other side, what happens to that number?
Goes the opposite.
Goes the opposite, changes sign. Fabulous. But I also want to move this one. I'm just going to do both at the same time, which means that when I move that negative 8x over, it's going to become positive 8x. And when I move that 3 over, it's going to become negative 3. Once it says equals 0, I can do the discriminant. For this problem, what is the a value? 1. Very good. The invisible number in front of x squared. What is the b value? 8. And what is the c value? Negative 3. Very good. I heard it. Make sure you know that that sign goes with the number. So when we are filling in my discriminant formula, b squared minus 4 times a times c, I know exactly where to put those numbers with tons of parentheses. So we have 8 squared minus 4 times 1 times negative 3. I'm going to let y'all do this one in your calculators. Let's figure out what this discriminant is. Okay, what'd you get when you type all that into your calculator? 76. Now that is a positive number. So what does that mean for us? What does this discriminant tell us? How many? 2. Are they real or imaginary?
Real.
They're 2 real. Oops, I spelled that wrong somehow. 2 real solutions. Remember, because it's any positive number, that means we have 2 real. The discriminant tells us a lot of information. I always like starting there, especially when we use the big quadratic formula later. I always still start with the discriminant. Okay, can y'all handle number 3 on your own?
Yes.
You got it. Remember, first it has to be set equal to 0, then you can do A, B's, and C's. You got it. If you're stuck on the first step, I'm going to do the first step up on the board. Okay, I'll let you think some more. So if I were to continue doing this one, because I've seen a lot of people finish, I know that once I have it set equal to 0, I can do the discriminant formula, b squared minus 4ac, to figure out the types of solutions. B is this number, negative 3. If we hadn't moved it to the correct side, we would have the wrong sign for this. That's why it's so important that we set it equal to 0. Then we're going to subtract 4 times A, which is 4, times C, which is 1. Very good. We throw that into a calculator, and we'd get the number negative 7, I believe. Negative 7. When you throw that in a calculator. Now let's make sure that, again, we did this correct. So I'm going to show you one more time on the calculator. For this one, we do parentheses. This time when we do negative 7, we need to go negative 7. then square it, and then make sure we switch to the minus. I said -7, it should be -3. Backing up. Minus 4 times A times C. All the parentheses, boom, -7. Now the fact that it is a negative number underneath that radical means that what type of solutions are we going to have? So we're going to have 2 imaginary, but if you wrote no real, that tells me the same information. No real solution means 2 imaginary solutions. Those are somewhat interchangeable in the context of quadratics. I would prefer us to start saying 2 imaginary instead of no real, but no real solution tells me that there are 2 imaginary. But let's start trying to use 2 imaginary. Okay, cool. How do we feel about using the discriminant? Just one little part of the quadratic formula. Do we feel okay about plugging that in? It's going to become a bigger part or a smaller part of the bigger problem when we go to actually solve the whole quadratic formula. But it's really not that bad. So we're going to use the quadratic formula to solve the following equations. Now remember, we're using the whole thing this time. So if you would like to take this picture version of the quadratic formula and use it over and over again, you totally can. Okay? I'll help you out on the first one for this. In number 4, to solve it, we need to identify A, B, and C. What's the A value here? 1. So if that was part of my picture, that's going to be the square, is the number 1. What's the value for B? -7. That's going to be my oval if you're using the picture. And what's the value for C? -18. That's going to be my heart. So if you do better using pictures, that's where you're going to put the different numbers in that formula. I'm just going to use parentheses like normal, but you totally can use that picture version of this. So go ahead and use that if you need it. For this quadratic formula, we're going to plug in everything we can. X equal to -b. So I'm going to do negative and then put b in parentheses. What's b? -7. Then the formula says plus or minus the square root of b squared. This part should feel familiar. B squared minus 4 times A times C. All of that divided by 2 times A. Whoa, let's pause for a second and get caught up. All I have done is take the numbers from this formula and put them into, numbers from the equation and plug them into the formula. The formula that's on the front of the page, the formula that's with the hearts, stars, and ovals, that's exactly what I've done. I'll give you a second to catch up. That is a great question, actually. So what we just did on the other page was the discriminant. That's just this part, the stuff underneath the square root. So just doing the discriminant doesn't solve the equation. It just tells me how many types of equations or types of solutions we would have. To actually solve it, we use the whole thing. But once we get it all plugged in, we're still going to start by doing the discriminant first. Which part do we simplify first? The discriminant. So everybody right now in their calculators, don't put anything other than -7 squared minus 4 times 1 times -18. Just the discriminant. That's all we're doing first. You want to write that down for yourself. So 1 is plug everything in. 2 is the discriminant. When we throw that discriminant into our calculator, what do we get out? 121. So what we will do is we will continue to simplify as we go. This part, -7. What's a negative? Positive. So I'm just going to write that as 7. Plus or minus the square root of, you guys said 121? So 121 over 2 times 1, which is 2. Woo, since my discriminant was the number 121, How many and what type of solution should I find? 2, are they real or imaginary? 2 real solutions, very good, because that's a positive number. At this point, all we need to do is simplify, and the simplify step kind of changes. Can you take the square root of 121? Yeah, what is the square root of 121? 11. When that happens, you literally, these are the easy problems. You can just take the square root of 121. You don't have to remember to simplify things like we did previously. At this point, because the symbol is called a plus or a minus, you have to do both plus and minus. So I'm going to split mine like this. We're going to have x equal to 7 plus 11 divided by 2, and x equal to 7 minus 11 divided by 2. I had to do both because that symbol says plus or minus. So I do both plus and minus. Well, those are just numbers. 7 plus 11 is 18. 18 divided by 2 is 9. 7 minus 11 is negative 4. Negative 4 divided by 2 is negative 2. Once I get down to just plain numbers, those are my solutions, and I'm done. If we were to graph this function like we learned previously, we would see that the graph crosses the x-axis at the value 9 and at the value negative 2. It has 2 real places that it solves the problem. So our steps again are plug in, do the discriminant, and then simplify. But the simplify step kind of changes from problem to problem depending on what type of number ends up underneath your square root. This one's pretty. We like this one. Can I do another one with you? Let's do number 5 together. On number 5, is it set equal to 0? No, so we have to set it equal to 0 before we start doing A, B's, and C's. So Stetron, if I were going to move this 4W to the other side, what would it become? Negative 4W, very cool. And then, Lauren, if I were to move this negative 1 to the other side, what would it become? Positive 1. Okay, cool. Once I have it set equal to 0, I can identify A's, B's, and C's. Zyriel, what is the A, B, and C for this problem? Okay. Very good. 1, negative 4, and 1. So we have everything we need to start plugging it in. I'm going to sing the song to myself so we can start solving. This time, since the value is not an X, it's a W, like technically we'll have to say W equal to negative B plus or minus the square root of B squared minus 4A C all over 2A. Ooh, the slowest Pop Goes the Weasel I've ever heard. I'll give you a second to catch up. I know I wrote fast. Okay, what did you guys get for the discriminant in number 5? 12. Okay, so when I start simplifying that, I have negative 4. Well, negative is positive, so I'm changing that to positive 4. Plus or minus the square root of 12 over 2 times 1, which is 2. Now, this being 12, what does that tell me the type of solutions I'm going to have? 2 real, 2 imaginary, 1 real. Which one? 2 real, because it's a positive number. Now, this is where it gets a little difficult. This is exactly where we were last time. However, can you take the square root of 12? And it comes out to a regular number? Guys, 12 is going to be one of those ones where you have to break down with a tree. How do I break down 12? 3 and 4. Can I break down 3?
Yes. No.
Can I break down 4? Yeah, 2 and 2, right? Okay, so I have a pair of 2's and a single 3. How would I rewrite this? Which numbers go out, the 3's or the 2's? The 2's. So the 2 is going to come out, and the 3 is going to stay underneath the square root. So I just simplified the 12. Now, once I do that, I'm almost there because I'm not going to get a decimal approximation for it. I want a nice simplified answer. So we're going to get here and we have to do the following. Do these numbers divide, 4 and 2? Do the number in front of the square root divide with 2? Yeah, cool. So I can actually simplify this. It's going to be 4 divided by 2, which is 2, plus or minus 2 divided by 2, which is 1, next to a square root of 3. Those are my two final solutions. What? I only have one thing written. Why is that 2 solutions? Not because there's 2 numbers, but that's kind of a good idea. It has to do with the plus or minus. Technically, this is actually 2 answers. 2 plus square root of 3 and 2 minus square root of 3, which will give me 2 different decimal approximation answers. So I still found my 2 real solutions like I knew I needed. They just comboed into 1 because I can write it in shorthand with the plus or minus. Okay, this is where it gets a little bit more difficult with this. Once you get here, then you have to decide how to continue to simplify. For this one, since I could not take the square root of 12, I broke it down the way we've learned and then simplified one more time. Okay, so number 6 is going to be for you guys to do, but I'm going to help you get started because it's kind of looking wonky. Is this one set equal to 0? No, and it's all over the place. I'm going to move everything to where the z squared is positive. I just like that number to be positive. So I'm going to take this and move it over here so that the z squared is positive. I'm going to take this negative 3 and I'll move it over here so that it's positive, which doesn't matter. I just want the z squared to be positive. Which means before I start actually doing a, b's, and c's, I would rewrite this as 4z squared minus 7z plus 3 equal to 0. Now I'm going to leave you here with a little bit of a hint, and I want you to find me the solutions to this quadratic. Starting with the quadratic formula, plugging everything in, doing the discriminant, and then finding my answers. I'll tell you right now as a hint, you should find one whole number and one fraction as your answer. A whole number and a fraction as your answer. If you're super stuck, I'm going to start working it silently on the board, but if you're still working, finish it before I get there. Okay, I got my work up on the board. Some of you got really, really close. I saw a bunch of people stall out right here when we were thinking about the types of solutions we'd have. This is a positive number. It's a small positive number, but it's a positive number. That means we're going to have 2 real solutions. And since the square root of 1 is 1, we're actually going to be able to find those numbers with no more radicals. So once I have it out of the square root, I can split it into 2 parts. I have the plus version and I have the minus version. The plus version ends up simplifying down to 1, and the minus version ends up simplifying down to 3/4, or 0.75. Before we move on from this one, I know some people got stalled out, so I'm going to request that we ask 2 questions before we go to the next one. Now that we're doing this last one, is it set equal to 0? Yes. All right, Yayla, you're telling me A, B's, and C's. What's A?
Okay, A is 32.
A's are always next to x squareds.
2.
2. Okay, what's B?
30, negative 30.
Negative 32. And what's C?
178.
Very good. Okay, cool. So we know the things that we're plugging into this formula. We just need to go plug it in. So we sing ourselves the formula as we go. X equals to negative B plus or minus the square root of B squared minus 4A C all over 2A. Ooh, that's a lot. Okay. So every single time we do it, we're just plugging in those numbers to the same formula. Once you get it written down, because I know I write faster than you, go ahead and do the discriminant and then pause so we can continue together. So Kylan got 400. So we're going to go ahead, or sorry, negative 400. We're going to go ahead and use that. Negative 32 would be positive 32. Plus or minus the square root of negative 400 all over 2 times 2, which is 4. Whoa, we've got a negative number in there. What does that mean? Everything I just heard is correct. We will end up having to take out the negative by making it an I. It also means we have no real solution or 2 imaginary solutions, which is also an indicator, if we have 2 imaginary solutions, that there will be an I, like you guys said, because we know they have to be imaginary. So what I'm going to do is I'm going to take the number 400, and I'm just going to scoot it over here for a second. Just 400. Imaginaries. I just shorthanded it. Okay, 400, we need to know the square root of it. Just as, in the off chance that this works, hint, hint, what is the square root of 400 in your calculator? Does it come out to a nice, pretty number? 20, because 400 is 20 times 20. Well, there's my pair. So instead of having to go make a whole tree, you can always try the number to see if it comes out to something perfect, which this does. So instead of, I'm going to mess this up actually, and I want you guys to fix it. What did I do wrong? No, well, the square root of 400 is 20, so it should disappear. Somebody said it earlier. Should be an I. Very good. There should be that I there because we had a negative underneath that square root. Don't forget my I. Also, you just said there has to be 2 imaginary solutions. There must be an I there. We are so close. This problem's a lot like problem number 5, where we can actually divide this. Do you see that 32 and 20 are both divisible by 4? What's 32 divided by 4? 8. Is that right? Yeah. 8. And then 20 divided by 4 is 5. My 2 solutions, my 2 imaginary solutions are 8 plus 5i and 8 minus 5i. But I can combo that together to just use the plus or minus button, essentially. Say again? Can I put dividing 20? What do you mean? I could have. That's actually a really good point. I could have, over here when I was doing the square root, kept going with 20, but I would have ended back up multiplying all those numbers to make 20. Meaning I would have 4 and 5 and 2 and 2 and then 5 and 4 and 2 and 2. Well, here's a pair, there's a pair, there's a pair. 2 times 2 times 5 is 20. So you could stop earlier just noticing that there's a pair of 20s. But yes, you could break it all the way down. That would be okay. It's just more work. So the quadratic formula works every time. It's especially helpful. It's especially helpful when the problem has imaginary solutions, because it's a way for us to find those imaginary solutions because they won't show up on a graph. It does take a lot of work because you have to plug everything in correctly, get here, and then be like, okay, well, how do I go from here? You simplify as much as possible every single time. Okay?